Hi, my name is Steven Yan. Welcome to my demo reel. I will present 4 main projects developed during my study at LaSalle College. Tyrant is a Unity 2D top-down tower defense shooter game created by a team of 8 programmers over 12 months. I designed and developed the quest system, which we use for our in-game tutorials to introduce the different game mechanics to the player. I created an abstract class quest, which defines the common interface for different quest types. Each quest has a text description of the objective the player must complete. Furthermore, it needs to evaluate a condition to detect when a quest is finished. For example, the shooting quest needs to detect if a certain weapon is fired. Using C# events, I can simply pass the reference of the target weapon to the quest, so it can listen to the on-fire event. Similarly, I connected the quest system to the room system via events to control the player progression through the tutorials. This allows me to unlock new areas of the map as the player completes each of the quests. Through this project, I gained experience designing and implementing a system that fulfills the project requirements and integrating with other people's code. I also learned the importance of writing clean and maintainable code, which positively impacts the productivity of a development team. StarCraft Simulation AI is the final project for the Artificial Intelligence course. Using a templatized finite state machine in my AI library, I designed and developed custom states for controlling the SCV and the carrier units. The default state of the SCV travels between the refinery and base to transport resources. The carrier wanders around and scans for targets. If the SCV enters the detection range of the carrier will enter pursuit state and chase after the SCV. The SCV will enter the evade state and flee from carriers. After the SCV leaves the pursuit range of carriers, both SCV and the carriers will return to their default state. The goal is for the SCV to gather as many resources as possible while staying alive. Hive is a custom game engine developed with C++17 and DirectX 11. I integrated Asset Importer into the engine in order to support importing character models and animations from FBX files. Also, I implemented a data-driven component system with RapidJSON, which allows me to create game objects easily. For my rendering engine, I added custom shaders to support dynamic lighting and shadow. I also added a pipeline support for post-processing so I can create special effects such as pixelation, night vision, and bloom. I developed the auto-driving and parking project with another programmer in senior portfolio class. Our goal was to create an AI that can drive a car and park a car in a certain spot. I was responsible for the AI's driving function. I modified the car controller to make it connect to the AI so that the AI can accelerate, decelerate, and turn. At the same time, I created the racetrack environment and set up the reward system. For example, the AI will receive rewards when driving forward based on its speed, and will receive punishment when hitting obstacles. In order to make the AI drive and turn more smoothly like a human driver, I also trained the AI with imitation learning by recording a demo and modifying the weight of behavior cloning in the AI. Through this project, I gained experience training an AI with different learning methods. Also, I have learned how to use PyTorch and TensorBoard to train and track the AI progression. However, training AI takes more time than I thought. I am still improving the AI by adding more training episodes and modifying reward functions. Thank you for watching, and don't forget to check out my LinkedIn page.